in that what happens, your minutes are also logged. So some people have attendance of like for the entire lecture, if it is of 1 hour, 1 hour, 1.5 hour, their attendance is 15 minutes. Okay, that attendance is not considered in that case. 15 minutes, it is less than 50% of the entire lecture. So I suggest you at least cross the 50% barrier. Okay, so if the, for example, if the lecture is of 1 hour, you at least be there for 40 minutes. Okay, so that's one thing to note. Please note that anything less than 50% or a few minutes will not be considered as attendance. Excuse me. Okay, next topic. VMs versus containers. Okay, traditional way business operates is by running applications on servers, database, email, web server. We have three different for all. VMs may we had one server. So okay, virtualization may we had one server. On that server we had VMs, and in that VMs we were running database, email, and web server. Now in containers, what happens? We don't have VMs, we have containers which run only that specific functionality. Okay, database, email, or web server. Let's get through the theory first. Application can't take full advantage of server capability. There is a link, I'll send it to you, which will tell you why it won't take the full server capability, or rather, I mean, even you can just type it out. Okay, why an application can't take full advantage of server capability. To resolve this, we came with VMs or virtualization. So here are a few disadvantages. Okay, consumes a lot of disk space. Then just a minute. Yeah, consumes a lot of disk space, consumes a lot of RAM and CPU power from the server, slow to start up, and each VM requires a license for each operating server. So how do we solve this issue? With the help of containers. Okay, a container is an application that has been packaged with all the files, configuration, dependencies necessary for it to run. Containers have small size, lightweight, fast, and consume less RAM. Okay, leading software used to create, manage, and run containers is Docker. Have you guys heard of Dockers?
Yes, sir.
Great. So Docker is a container company. Okay, it provides containers. So previously, what was happening? We had this server. Okay, and then we have bare metal. Then, as in the hardware, we have the OS. We have the hypervisor. Okay, hypervisor, OS, hardware or bare metal, and then we had VMs on it. Okay, so these VMs were fully equipped with everything, like how a computer is. Okay, how a server is. It had everything. It had OS, all the files, all the processes, applications, images, and everything. Okay, so this is running database, this is running email server, and this is running, let's say, a web server. Okay, so now what in containers it happens is, let's say there is a website. What does a website need? It needs images. Okay, it needs scripts. Okay, the scripts may JavaScript, it will need HTML, CSS, everything, whatever it is, HTML, CSS, JavaScript. Uske साथ, what does these need? They need an environment to run. Okay, and what with the comes with the environment comes libraries. So all of this is packed. Okay, all of this is packed and put into something called as container. Okay, and then this container is directly run on the OS. Now we don't need a VM. Okay, if let me see if yeah, you have the hardware, operating system, container engine, and it is directly run on the engine itself. Okay, here in this case, engine will be Docker. Okay, so you have the hardware, you have the OS, you have the Docker, and then directly the applications, the container. Okay, in this container, we run the applications. Why this happens is because, see, containers have smaller file size, lightweight, fast. So instead of booting up the entire PC VM में जैसे होता है, here we do not need to do that. Okay, your Windows PC जब boot up होगा, it will boot up the it will make the containers work as well. उसमें OS की कोई जरूरत नहीं है. OS के जो भी processes होते हैं वो शुरू करने की जरूरत नहीं है, उनका प्रोग्रामिंग करने की जरूरत नहीं है, अपडेट करने की जरूरत नहीं है, सिक्योरिटी चेक करने की जरूरत नहीं, कुछ नहीं. That is why containers are mainly preferred over virtual machines. But nowadays you can include both. Okay, include both in the sense ki in this itself, in these VMs itself, which are running Linux, probably Unix, inke andar hi you can make containers. Okay, you can have dual functionality as well. So on your hypervisor, if you have VMs, different VMs, you can run the containers on these VMs as well. It gives you dual functionality. Okay, why dual functionality? Because you can run multiple operating systems on one server. Okay, the disadvantage over here is that कि अगर तुम्हारा OS, ओरिजिनल OS विंडोज है, तो तुम्हारे कंटेनर्स भी विंडोज के ही होने चाहिए. Your containers also need to be of Windows. ठीक है, तो जो हम ये बात कर रहे थे, लाइब्रेरी, स्क्रिप्ट्स एंड ऑल, ये भी ऐसी होनी चाहिए जो विंडोज पे रन हो सके. ठीक है, these can the configurations, ठीक है, the settings, the way, the syntax, और जो भी जैसे भी लिखा है कमांड्स का syntax, this all needs to be in the form of Windows, something that will run on Windows. ठीक है, that's the main disadvantage कि तुम्हारा कंटेनर भी उसी का होना चाहिए. That is why dual functionality जैसे कि तुम VMs पे रन करोगे. Okay, on your VMs you'll run containers. Why? So that you get dual functionality. You get different OSs, Linux, Unix, and plus different containers. A container that is running on Linux, a container that is running on Unix, a container that is running on something else, Mac OS. Okay, dual functionality is possible. Another disadvantage is कि इसमें कैसा है, अपने original scenario में you had the hypervisor and then you had the VMs. Okay, तो अगर ये VM fail हो गया, it does not affect this or this. But in the container situation, right, we have only one OS, the original OS, or let's say Docker engine. ठीक है, और इसमें अगर ये OS fail हो गया, then everything fails. Each and every application fails to work. Okay. Next, this is how containers would look. We have a hardware, operating system, container engine. As an example, you have Docker, and then you have applications running on it. If you go further, you can go to Docker. ठीक है, Docker की official website है. You don't need to download the product, but they do have somewhere they have documentation. Yeah, तुमको डॉक्यूमेंटेशन पढ़ना हो या फिर कभी कभी कम्युनिटी पे जाओ, दे पोस्ट FAQs and then it's better to understand FAQs क्या होता है. YouTube पे भी बहुत मिल जाएगा डॉकर का, स्पेसिफिकली डॉकर. ओके, not about the concept of containers but about the Docker as a company, because this is very specific. Okay, this is how it looks. So you have containers, okay, this running, how much CPU, ports, and everything. Next, overlay networks. Okay, let me see how much it is. Overlay networks is a little bit new, you can say, kind of new. So imagine कि तुम्हारे normal roads हैं, okay, it forms the network, and तुमने उस पे bridges बनाए, okay, pool बनाए, and you form new what you say ways, ठीक है. तो ये हो गया overlay network. म्हणजे तुम्हारा जो already एक network है, okay, this is already your network. For example, इसके ऊपर तुम एक और network बनाते हो, okay, which goes like this, and like this. So this is your overlay network. Something that is already there on your existing network is called overlay network. Okay, I'll try to make another example. For example, जब हम VPN use करते हैं, okay, what it makes, it tells you कि you are in the in some different country while using it. Okay, so for example, suppose this is my building, okay, and each floor there are two computers. Okay, there is one PC here, one PC here. Let's say one, and we have multiple routers. Okay, then we have some servers. These are all public. Now since these are public, even company uses them. Okay, this is a company, this is a building, home PCs, and this is company private PCs. Okay, let's assume there are like 3, 4, God knows whatever. And they all are later connected to the internet. Now, how the actual, let's say, there is already a network. What is the network setup? That each of these PCs, okay, is connected to either this router or this router. Then it goes to this server, then to this server, and finally to the internet. For a company, it is like each of these is connected to either this router, okay, then it goes to this server, then this router, then this server, and finally to the internet. Okay, this is my original network. Now in overlay network, what will happen on this existing, this is my existing network, I will build a separate network, private network, which will make my connection to the internet. Okay. Now let's assume I connect to the VPN. VPN में क्या लगता है? The network thinks that I am not in my home, but where I am actually in office. Okay. So on this existing network, my network now becomes that I have moved from here to here. So traffic will flow from here to this router, to this server, again from this router, because this is the company router which is there. Okay, it assumes I am here, from here to this server, and then to the internet. Now, what my PC looks like is, assume that it is in the company building. Okay, so for him, the network is this. This is my PC. Traffic goes from here to here, server to this server. He's actually in this company building. He thinks so. So assume that this is the whole network, and then to the internet. Okay, so on an existing network, okay, a different network is formed, which is private or creates new routes, which is called an overlay network. This is possible because of virtualization. You can imagine that my PC has shifted here. So he's basically connected to this network. This is my network now. And this entire thing comes under the company. That's how overlay networks will work. Okay. So they work by creating a virtual layer on top of an existing physical network infrastructure. Okay, allows for abstraction and virtualization of network resources, enabling implementation of specific network topologies. So first step is virtualization and abstraction. Okay, uses virtualization to create a logical and virtual network that operates independently on the physical network's characteristics. What was my physical network here? This is my original physical network over here. Okay, this, there's a building, there are routers in between which are public, there is companies, both of them use it and it goes to the internet. How I made it virtualized or private? By using a VPN, moving this over here in the company, and now my network is either this router, this public and this downwards, or from here, this entire thing. Okay, where I have this one router, this server, sorry, not this router, this server, this center router, this server, and down. Okay, so my topology is from here to here, either or the other way around, from the company side, from the home side, from the company side, assuming how the VPN is set up. This abstraction allows to create customized network architectures without directly impacting the physical infrastructure. Tunneling and encapsulation to achieve communication between devices. Packets from the virtual network are encapsulated within the packets of the physical network. ठीक है, तो basically it's like कि तुम्हारा जो ओरिजिनल पैकेट है उसको तुम एक और पैकेट में डालते हो. वाई? जस्ट बिकॉज जो ओरिजिनल नेटवर्क्स है, जो ओरिजिनल ये थे सर, राउटर्स थे, उस पे जा सके. तो कैसा है? ओके, लेट्स टेक दैट एग्जांपल अगेन. सो वी हैड two routers, one server, routers, server, and server. Okay, so the original packaging should go to the internet. Okay, but like I said, what is it? To achieve communication between devices in the overlay network, packets from the virtual network are encapsulated within the packets of the physical networks. अब मेरा पहला पैकेट virtual है. Okay, what, as in I'm connected to VPN, which tells that my home PC is actually in the company. तो मेरा जो बाहर का पैकेज है वो कैसे होगा? वो यहां से ये राउटर पे जाएगा. Okay, then this router back to this router, and as if it is in the company. ठीक है, ये PC से. Then from there it goes back to this router. अब अंदर एक छोटा पैकेट है. Okay, वो छोटा पैकेट यहाँ to this router, to this server, and बाहर इंटरनेट पे. Okay, that is how it goes. In reality, it directly goes like this. It's just that because of VPN, it is assumed that it is in the company. Okay. Overlay. Now, overlay networks have their own different protocols. Okay. Common protocols include VXLAN, GRE, and NVGRE. Endpoints, overlay endpoints matlab nothing but the actual machines. Okay. Which can be virtual machines, containers, and other network devices communicated within the overlay networks as if they are on the same logical network segment. Okay. So something that you have overlaid. Okay. Overlay endpoints matlab agar tumhara original, this is the original setup. Okay. Where these are routers, this is server. If you have virtualized or made an overlay network, then this is your overlay network. Okay, this red thing is your overlay network with overlay endpoints. What are your overlay endpoints? This router, this server, this router, and this server. The original is all that is in the black. Okay. So overlay endpoints are machines, VMs, containers, routers, switches that are virtualized to form a overlay network. Overlay control plane, again, this is something that is virtualized, so it can be managed by an SDN. I've told you, we have learned SDN before. I told you yesterday, it is software defined networking. इसमें इंडिविजुअल कंट्रोल जो राउटर या स्विचेस पे होता है, वो उनसे छीन के एक सेंट्रल सर्वर पे डाल देते हैं, ताकि सेंट्रल लोकेशन से सब कुछ कंट्रोल किया जाए. ओके, लाइक आर एक्चुअल ट्रैफिक सिग्नल्स. इंस्टेड ऑफ सबके पास टाइमर है, एवरी सिग्नल इज सेट फॉर 60 सेकेंड्स. ठीक है, तो इंस्टेड ऑफ गिविंग द एबिलिटी टू ईच ट्रैफिक सिग्नल ऑफ 60 सेकेंड्स, वो पूरी तरह से हटा के सेंट्रल लोकेशन पे डालेंगे. नाउ वी हैव द एबिलिटी टू कंट्रोल ऑल द सिग्नल्स फ्रॉम अ सेंट्रल लोकेशन एज पर आवर नीड्स. तो मैं कोई सिग्नल 30 सेकेंड्स पे चालू करूंगा, कोई 20 पे, कोई 60 पे, एंड as and how I need it. Okay, so it's that the overlay network का control, okay, each individual से हटा के central पे डाल देते हैं, and which is controlled by SDN. The control plane is responsible for configuring and managing the overlay network, ensuring that endpoints can communicate effectively. Okay, the SDN controller or another mapping mechanism is responsible for translating virtual addresses to physical addresses. ठीक है, यहाँ पे virtual address होगा. Since your original network will have some addresses, okay, 1.0, 192.168.1.1. Now once you overlay it, okay, and this is the connection, they need virtual addresses, virtual IPs. So now the new virtual IP is 168.0.2, and this needs to be mapped with this, क्योंकि जैसे मैंने कहा था पहले, बड़े पैकेज में क्या एड्रेस होगा, 172.168.0.2. ये कैसे होगा, ये बिकॉज ऑफ दिस एड्रेस द नेटवर्क अज्यूम्स कि ये पैकेट कंपनी का है और घर का नहीं है, बिकॉज आई एम कनेक्टेड टू द VPN. और अंदर एक पैकेट होगा जिसका एड्रेस होगा 192.168.1.1. क्यों, क्योंकि हमें अभी भी ओरिजिनल नेटवर्क पे इसको भेजना है. Okay, that is why. So you need a mapping of 1 to 1, where 172 virtual IP, 172 virtual IP is mapped to the actual physical IP of 192.168. Network virtualization. Overlay networks provide network virtualization, allowing multiple logical networks to coexist on the same physical infrastructure. This is particularly useful in multi-tenant environments where different users or applications require isolated environments. So अब कैसे हुआ? On this original network, I can have multiple, because of virtualization, I can have multiple networks. Like I said, for example, in this previous one, इस public network पे there was private home networks as well as company networks. So because this public is virtualized, or I have paths virtualized on it, overlay networks on it, a single infrastructure is used by multiple tenants, okay, where different users or applications require isolated network environments. Different paths, different environments, networks are used by multiple people. Overlay networks and dynamic and configured on the fly. Again, this, I mean, it is like the ease of customizability. Security and isolation, again, because it is virtualized, everyone has their own network, private network. It is isolated and it is secure because the original underlying network, even if hacked, they cannot enter into the private network that you have created. Okay, So overlay networks provide level of security by segregating traffic within virtual network. Different networks coexist on same physical infrastructure. I know this is a little difficult to understand, but I hope with this you at least have an idea. Okay? There is a, what do you say? There is an original infrastructure, actual devices जो तुम्हारे घर पे होगा, वो राउटर, मोडेम, उसी से ओरिजिनल बनता है और उस पे तुम एक अलग से नेटवर्क बनाते हो. तो फॉर एग्जांपल मान लो तुम एक बिल्डिंग में हो अपने दोस्तों के साथ, ठीक है. ओरिजिनल क्या होगा, सबके घर में पीसी होगा, राउटर होगा, मोडेम होगा. ओके. नाउ सो ओवरले नेटवर्क क्या होगा, जब तुम तीन दोस्त फॉर एग्जांपल, एक रहता है 6th फ्लोर पे, एक रहता है 3rd फ्लोर पे और एक 1st फ्लोर पे, जब तुम तीनों कनेक्ट करोगे या फिर तुम्हारा एक छोटा नेटवर्क बनेगा, दैट इज कॉल्ड एज ओवरले नेटवर्क. मतलब एग्जिस्टिंग इंफ्रास्ट्रक्चर पे तुमने अपना खुद का एक नेटवर्क बनाया जिसमें 3 पीसीज, 3 राउटर्स, 3 मोडेम्स है और तुम अलग से बात कर सकते हो. तुम्हारा कॉन्वर्सेशन कोई सुन नहीं सकता है, कोई हैक नहीं कर सकता, आइसोलेटेड है. और जो ओरिजिनल इंफ्रास्ट्रक्चर है, अगर उसमें कोई प्रॉब्लम भी हुआ, लाइक इफ समवन कम्स टू हैक और लिसन, he cannot get into your private friends network. Okay, that's the whole point of overlay networks or how it works. उसके लिए अलग से ये लगेंगे, क्या कहते हैं, protocols, VXLAN, GRE, NVGRE. Again, this is for self study. And please do self study, इस पे questions होंगे. VPN. How many of you know VPN? I mean, use तो सबने किया होगा, that's for sure. Do you guys know how VPN works?
Yes, sir.
Okay, great. Then it's easier to grasp and explain. I'll go through it quickly. But only one person has said so. Others,
फिर ये लोकेशन चेंज करते थे.
but okay. Functionality, you know. Do you know actually how it works? Matlab, how does it change the location?
सर दूसरा आईपी एड्रेस देता है वो.
Yes. Yes. Good. Okay, great. Okay, I'm assuming you already have an idea, so I'll quickly go through it. If you guys have any doubts in between, please do let me know. Okay, so okay, establishes a secure and reliable network connection over unsecure network, protects internet activity, will encrypt and protect your internet data, encapsulates the data. You will be able to access restricted content. No third parties such as ISP, government can see the contents of your data or its destination while the VPN is active. Okay. How does it go? VPN tunneling. Okay, when you first connect to a VPN, your device and the VPN server platform perform a handshake and exchange encryption keys. This ensures that only the VPN server can encrypt data sent from your device, and conversely, only your device can decrypt data. Yeah. Okay. So client secure session from the server, authentication is there, encrypted key is sent, and session is encrypted. Okay. This is how it goes. So VPN client, encrypted connection to server, not encrypted, and goes to the cloud. Okay, we'll come to this tunneling again. I'll show you how it goes. Okay, just a minute. तो अभी सिनेरियो में so how does the scenario go? I have my PC. उस पे what I say, connect to VPN. Then the connection goes to VPN server, and from the server it goes out to the internet. Now in this, okay, my original IP, what's my original IP? One 192.168.0.102. 192.168.0.102. Okay. Now, and what is my original IP address? ठीक है, 116. तो अभी सिनेरियो कैसा है? Right now I am directly connected PC 168.0.102 is directly going to the internet with the public IP of, क्या था भाई, 116, sorry, 116.74 dot, oh my god, 162.202, 62.202. Okay, पहली बात, we have already learned this. ये IP इसमें कन्वर्ट क्यों हुआ है? You guys don't remember?
ये public IP address.
Yes. And why? Why public IP?
Sir, to reach the internet.
Yes. तो प्राइवेट IPs वर्क नहीं करते क्या इंटरनेट पे?
सर सर्वर रिस्पॉन्ड नहीं कर सकता प्राइवेट आईपीस को.
Yes, correct. Okay, so internet पे only public IPs work. Private IPs do not work. Therefore, it is necessary to convert private IP to public IP. What is this conversion process called? Again, I have mentioned, but we have not gone deeper into the topic, but I've mentioned the name of the process.
Network address translation.
Great. Network address translation. Okay. Sorry, I don't have this window open. Who answered?
Sir, me.
Prathamesh. Nice. Okay. Okay. So it's network address translation transferring to this. Now let's see what happens when I connect to the VPN. Connection will go for a few seconds. Remain on call. Okay. Before that, I'm stopping the screen share. Okay. Wait on call for a few seconds. Okay, everybody is still there?
Yes, sir.
Great. Okay. Now, this red line is the VPN company's network. Okay. It is their own private infrastructure, whatever you want to call it, network. I am now connected to the VPN. Okay. So if you go here, go to settings, what do you see?
So the screen
Server
is
address.
not visible.
Oh, right. Sorry. Hmm? Oh. So connected to this red is the VPN network, their own network in their own infrastructure, उनका जो भी वो provide करेंगे. Okay. So my IP is now connecting to what you can see it here, server address. Okay, 149.173.768. So this VPN server address is 149.173.7.68. What is my address? 172.16.45.4. So my address is 172.16.45.4. Okay. And for the internet, what's my IP? See, 149.173.8.69. 149.173.8.69. It is for the internet. My address is 149.173.8.69. And my location has gone from India to North Carolina. Okay. This is India and this has become North Carolina. Okay. Understood? Now, why did my IP change from 172? Because when it is going out, it is going as public only. This is the server IP address. सर्वर के पास कुछ अपने खुद के पब्लिक आईपी का पूल है. पब्लिक आईपी पूल, पूल एज इन बहुत सारे आईपी है. उसमें से उसने एक उठाया, मुझे असाइन किया, मतलब मेरे कनेक्शन को असाइन किया, and now I can go through the internet via North Carolina. Why was this need there? Why did he convert my 192 to 178 beforehand? Okay, so the reason being कि इनका जो खुद का नेटवर्क है उसके लिए भी मैं anonymous हूं. They don't know who I am. Okay, it is very important to keep the privacy. ठीक है. So for them, जब मेरा 192.168.0.102 जब VPN सर्वर को कनेक्शन बना, तो the connection was actually coming from my original public IP address, जो यहाँ पे ये वाला. Okay, so what he did was, उसने ये मतलब VPN जो कंपनी है, ठीक है, उनके लिए कनेक्शन कहां से आ रहा है? यहां से. ओके, और उन्होंने इस पब्लिक को कन्वर्ट किया प्राइवेट में, विच इज 172.16.45 जो यहां पे है. 172.16.45 4 72.16.45 4 which is for me. Okay, this is a private connection for me. तो उस कंपनी को पता है कि ये जो प्राइवेट आईपी एड्रेस है, इट इज मैप्ड to this public IP. They don't know that I am 192.168.0.102. This is only internal. ठीक है, उनके इंफ्रास्ट्रक्चर में this is the connection. That is why I have mentioned कि ये connection कैसे होता है in VPN network में. उनके इसलिए for them connection came from this public. Since it is public, it had to be converted into private. अब उनके इंफ्रास्ट्रक्चर में क्या है? देयर इज अ प्राइवेट आईपी 162.1645.4. इट इज कनेक्टेड टू अ सर्वर जो कि ये वाला है यहाँ पे 7.68 एंड ही नीड्स टू कनेक्ट टू द इंटरनेट. अब इंटरनेट को कनेक्ट करना है तो उसको एक पब्लिक देना होगा विच इज व्हाट दिस वन 149.73.869. ठीक है, वो वाला दिया 8.69 एंड इट इज कनेक्टेड. अब कोई रिप्लाई आएगा, सपोज एक लॉगिन पेज आया, इस पब्लिक से इस सर्वर पे आएगा, सर्वर से इस प्राइवेट पे आएगा. दिस प्राइवेट नोज दैट द पब्लिक इज 116 और उसके इंटरनल जब मेरे अंदर होम नेटवर्क में आएगा तब इट नोज दैट 192.168 is the original IP address that is mapped to 116. Okay, this way my original identity okay, in this way my original identity is never revealed. Okay, and in that infrastructure the company only knows public mera and the private that he himself has given so that the connection is possible. Okay, that is what tunneling is. So this is the tunnel. ठीक है, ये मेरे पीसी से एक टनल है सर्वर तक और सर्वर से इंटरनेट तक. दिस फोटो ओवर हियर. ठीक है, my client which is the Cisco, then I have encrypted connection to the server. Which server? This 149.173.768 and वहां से फिर बाहर to whatever it is. Clear?
Yes, sir.
Okay. Again, theory. So data coming from the internet goes through the same process in reverse. Oh, sorry. पहले नहीं होती. हाँ. Once the connection is established, your device and the server can securely transmit data back and forth through the tunnel. This is the tunnel that I'm talking about. ठीक है, from my 192 to public IP, public से इस server पे, and the tunnel is from public to server. ठीक है, from here to server. Data is encrypted with the key before it leaves your device. When it reaches the VPN server, it is decrypted, then forwarded to the final destination. आते वक्त this process is reversed. The tunnel analogy comes from the VPN's encryption. Data can go back and forth between the tunnel, but there are only two endpoints, your device and the VPN server. VPN addressing involves the assignment of IP addresses to devices within the VPN using a specific address scheme. The address scheme that I just explained. Okay? Private to public, public to the server, a connection is formed, a public is given a private because company को भी खुद को एक ट्रैक रखना पड़ेगा ना, उनको भी तो पता होना चाहिए कहां से आया है, कहां जा रहा है, किसको क्या देना है. उनके खुद के रिकॉर्ड के लिए भी तो एक प्राइवेट पब्लिक होना चाहिए, मैपिंग होना चाहिए. That is why the public is then converted into private 172, which is their own. It goes to the server और सर्वर कोई एक पब्लिक चूज करके which is 8.69 बाहर इंटरनेट पे भेज देता है. Okay, this is what the addressing and forwarding scheme is. VPN forwarding encompasses the routing of data through the VPN infrastructure. The VPN infrastructure, this red line, this VPN infrastructure. Okay, often involving tunneling protocols and encryption decryption process to ensure secure communication. ठीक है, again it's I'll just quickly read this out. Okay, it is the same thing that I just showed you. So within a VPN, devices are assigned IP addresses just like traditional network. These are often private IP addresses and are unique to identify each device in the VPN. Addressing scheme used in VPN depends on protocols involved, VPN used, ठीक है, कोई भी private दे सकते हैं, and the definition is in RFC 1918. VPN can use static, manually configured or dynamic IP addresses for devices within the VPN. Dynamic methods may involve protocols like DHCP. अब हम घर पे होम नेटवर्क है, इसीलिए we have DHCP, ठीक है. In a company, they are statically set, ठीक है, उनको तुम ज्यादा चेंज नहीं कर सकते क्योंकि कंपनी वो खरीदती है. तो जब वो लाइक अभी ये VPN जैसे सिस्को का है, तो मेरी कंपनी हुई तो मैं सिस्को के पास जाऊंगा, उनको बोलूंगा कि मेरे पास 5000 पीसी है और मुझे हर बार मैं जब तुम्हारे इंफ्रास्ट्रक्चर को कनेक्ट करूंगा, मुझे सो एंड सो स्टैटिक आईपीस चाहिए, ठीक है, ताकि बाहर के जो लोग हैं, बाहर की, सपोज मेरी कंपनी इज कनेक्टिंग टू कोका कोला, तो कोका कोला को पता होना चाहिए कि अगर आईपी एड्रेस यहाँ से आया तो वो एक्चुअली मेरी कंपनी से आ रहा है जो कि उनका कस्टमर है. ओके, सो फॉर कंपनीज इट इज मोस्टली स्टैटिक. फॉर होम, लाइक people you and me who are working from home, starting from home, they have dynamic address assignment. ठीक है. Routing of data, VPN forwarding involves the process of directing data packets from source to destination within the VPN. Tunneling protocols तो मैंने बताया. So there is SSL and TLS tunneling protocols that are used in VPN. VPN forwarding includes encrypting data at the source and decrypting it at the destination. In this case, it is only till client to server. Okay. Routing tables. VPN routers maintain routing tables that specify how data should be forwarded within the VPN. Of course, like I showed you over here, you have to maintain a table. Okay. उस टेबल में क्या दिखाया जाएगा? Because you have to maintain a table in the infrastructure. And what is the table? It shows that 172.16 is mapped to this 149.173.8.69. This is in a table. It also maps that 116.49 is actually associated with 172.169A. This table needs to be maintained by, क्योंकि पता होना चाहिए कि source कहाँ से आया है, what is destination, और जब उसका reply आएगा तब how it should go. Okay, so this table needs to be mentioned. Destination will become source and source will become destination in the reply. Okay, a table is maintained, routing table, so that data transferring is maintained. Exactly what I showed you. I have a private, it gets turned into public, goes to the internet, and vice versa. Okay. Network address translation, the conversion of private IP to a public IP, okay, is the process in which one or more local IP addresses is translated into one or more global IP addresses and vice versa in order to provide internet access to the local host. Okay, it does the translation of port numbers, that is mask the port number to the host with another port number in the packet that will help be routed to the destination. Okay, NAT differentiates between responses by using a technique known as port mapping, especially with the use of unique port numbers for each connection. This process, often referred to as port address translation or network address translation and port translation, NAPT, enables multiple devices within a private network to share a single public IP address. Okay. Just a minute. Okay. Okay. How many of you are in Pune or Maharashtra, for say?
Sir, I'm currently in Pune, but not from Pune.
No, no, yeah, that's fine. I'm just saying because I wanted to show how the um this port address translation or the network would go. So what do you guys do is just type what is my IP address in google.com, and whatever your public IP is, just send it to me in chat and we'll connect in 10 minutes. Okay, let's meet again at 10:35. We'll continue with the next topic. Please put your IP addresses in chat. Okay. Sharing my screen again. Okay, where were we? Network address translation and how it is related to port address translation. Okay. So what I wanted to show you now, as you can see, all your IP addresses are different. Okay. In this case, in your case, Mobita has 103, Prathamesh has 183. Okay. Kunal 152, Shubham 106. 1, 2, 3, 4. Out of 8 people, half have answered. Okay. Before we, there were 7. 4 answered. Okay. So in this case, it is a one-to-one mapping. Okay, Momita's private is converted into 103. Now, if you see, I cannot convert this back. Okay, I don't know what Momita's private IP address is. So this is kind of a security feature, okay, of network address translation. Helps you be anonymous. Okay, so this is one type where one-to-one IP address is done, 183, 103, 152, 106, because everybody is on different network. Now there is another type where multiple private IP addresses are given the same public IP. So for example, in my building or in my area, suppose, let's say 2 kilometers, 2 किलोमीटर्स के रेडियस में जितने भी प्राइवेट आईपी एड्रेसेस हैं, all of them will get the same public IP. And how does this work is, let's say mine is 192.168.0.1. Okay, then there is 2, 3, 4, so on. All of them get a public IP address of 116.74.162.202. 116.174 और क्या था, सॉरी 74.162 74.162.202. okay, now how do I differentiate कि कौन सा private is कौन सा as per the connection? That is taken care of by ports. Okay, and the table or the conversion is called ports address translation or PAT. Now how it looks? Okay, now let's say all of us are making connections to a web server. तो उस केस में कैसे होता है? So now you have your private IP addresses 192.168.0.1, 192.168.0.2, 192.168.0.3. And now when the connections are made out the internet, you get the same IP 116.74 1 क्या था 62.202 and a port is added, let's say 45,000, then 116.74.62.202 4,500 and 45,501. So this is private IP, public IP, and a port. Okay, same to 45,002, and the connection has gone to the web server, which is www.abc.com at port 80. This probably goes to 443 since it is HTTPS. This is HTTP. or you can keep all at 80. What is the deciding factor here? Ports, port address translation. Now the system knows अगर पोर्ट 45,000 पे आए तो डेटा कहां जाना चाहिए? 01 के पास. अगर यहां पे आए या फिर यहां से आए, सो कमिंग टू पोर्ट 45001 or coming to this or coming from this, where should the data go? It should go to 02. यहाँ पे it should go to 01 and यहाँ पे it should go to 03. Okay, so either 1-1 or given from a pool. Okay, there is one more like 3. There is like 1-1, there is 1 to many, and there is many to 1. Okay, so like the types are की एक प्राइवेट आईपी टू एक पब्लिक आईपी, एक प्राइवेट आईपी टू अ पूल ऑफ पब्लिक आईपीज, तो या फिर पूल. ठीक है, सो प्राइवेट टू पूल या फिर पूल ऑफ प्राइवेट टू पूल ऑफ पब्लिक, दिस कम्स इन वन कैटेगरी. या फिर जो मैंने अभी दिखाया, ओके, मेनी प्राइवेट्स, पूल ऑफ प्राइवेट टू सिंगल public. Okay, these are the types of natting. उसको क्या बोलते हैं ये गूगल पे देख लो, मिल जाएगा. Now, interaction between NAT and ICMP. ICMP messages, you remember in the previous PPT I had shown you what are ICMP messages. We have gone through it. Okay, just gonna give you a quick recap. ICMP is like a messenger in computer networks. It helps devices communicate and troubleshoot issues. Here are a few types and codes and descriptions of it. Okay, if I'll pause it over here for a few seconds, 2 seconds, you when I give you the PPT or you go through the recording, you can go through the theory. Okay, destination host reachable, host unreachable, ये मैंने बताया था. जब तुम पिंग करते हो और कुछ नहीं मिलता तो you get a error like this. Even in last week Saturday or Sunday we took one this lab, उसमें we were trying to reach to www.yastraj.com और वहां पे host unreachable error आया था. Okay, that way. So this is the error stateful tracking and considerations जो होता है. So if there is a problem, devices might send ICMP error messages. NAT needs to understand these messages and make sure they get to the right place. Think of the NAT device as a smart post office. It keeps a list of who sent what and where it should go. Allowing ICMP is letting certain types of mail through, but too much can be risky, whatever the security consideration is. Okay. Now, why the interaction matters? Because basically क्या है कि ICMP is the protocol or message that tells the sender कि problem कहाँ है. ठीक है, अगर मैंने यहाँ पे कुछ पिंग किया, पिंग 123.56.0.43, ठीक है. So when I do ping, an ICMP message should come back telling that request timed out or some error जो इनमें से one of these errors. Destination नहीं मिला, source route fail हो गया, unreachable pointer या so on. ठीक है, something like this should come. Okay, but the interaction matters. Why? When you send it out on the internet. तो जब तुम पिंग करते हो for something on the internet, like for example अगर मैंने गूगल को पिंग किया, ping 8.8.8.8, you are getting a reply back and it says received. Now in this case NAT matters because Google should not know कि मेरा private IP address क्या है. Okay, so the natting should occur and ICMP का जो प्रोटोकॉल है, जो मैसेज है, जो एनवेलप मैंने भेजा है, this I send an envelope, right? उसमें क्या लिखा है 8.8.8.8, उसमें एक सोर्स होगा और डेस्टिनेशन तो ये है. ओके, so it is very important for ICMP to make sure कि my private IP is not revealed. This is the first functionality. Second, functionality in the sense why the interaction is important. Second, because अगर कुछ error हुआ या फिर कुछ reply हुआ, he needs to be able to send it back to me. Okay, so उसको ये भी याद रखना पड़ेगा कि जो मैपिंग हुआ है वो ठीक से हुआ है कि प्राइवेट का टू पब्लिक, बिकॉज जो भी होगा, सपोज कोई एरर आया तो ये एरर वापस सोर्स को भेजना है, राइट? एंड इन दैट केस ही कैनॉट सेंड इट टू द पब्लिक, क्योंकि वो पब्लिक है, उसको भेजना पड़ेगा प्राइवेट को. सो दैट इंटरैक्शन और मैपिंग इज इंपॉर्टेंट वेयर private is given to public. So ICMP also needs to make sure this mapping is taken care of, because उसको errors जो भी आए हैं इस कनेक्शन में, when I said ping 8.8.8 में, वो वापस सोर्स को भेजने, which is my IP address. Okay, but this cannot be shown when it is sending out, neither it can be shown when reporting the error. Okay, so the interaction refers to how NAT devices handle ICMP packets, such as those used for network diagnostics, example ping, error reporting and control messages. Since ICMP packets contain important information about the originating system, NAT must properly translate the addresses in these packets to ensure correct communication. क्यों मैटर करता है जो मैंने अभी बोला? ओके, जस्ट इन थियोरी कि NAT translates private to public, it must also update the source inside the payload. Failure to do so can cause issues with the communication, such as drop package. So अगर, like I said, it needs to map it properly. अगर नहीं किया तो पैकेज ड्रॉप होगा, क्योंकि क्या होगा, आइदर वो डेस्टिनेशन नहीं मिला, अगर डेस्टिनेशन नहीं मिला तो पैकेज ड्रॉप, और अगर सोर्स नहीं मिला तो पैकेज ड्रॉप. सो ICMP needs to make sure कि नैटिंग is done properly और उसका रिकॉर्ड कहीं पे रखा जाए. अगर नहीं रखते हैं तो पैकेज विल बी ड्रॉप्ड. इफ पैकेज इज ड्रॉप्ड, आई विल नेवर नो कि डेस्टिनेशन रीचेबल था या नहीं था, क्योंकि मुझे कभी वो एरर मैसेज फिर वापस मिलेगा ही नहीं, आएगा ही नहीं. ओके, दैट्स व्हाई द इंटरैक्शन बिटवीन NAT एंड ICMP इज इंपॉर्टेंट, एंड दैट इज हाउ इट इज डन. कि पैकेट में वो मैपिंग इज नोटेड. ओके, all right. Now that everyone is still there, again, I'm repeating my point, which I told at the starting of the lecture, that if a lecture is, like, for example, this one is 1 hour, 17 minutes. Okay. 50, if you're, and the Microsoft automatically marks the attendance. If I show you this here, this attendance, this is directly calculated. Okay, I have nothing to do with it, Microsoft does it on its own. उसमें minutes भी calculate होते हैं. तो अगर पूरे 1 hour 20 minutes के lecture में, if your attendance is only 15 minutes 20 minutes, it will not be considered, क्योंकि 90 minutes के lecture का half is 45 minutes. If you're not there for even half the time, your attendance is not marked. So please be careful, make sure that you are there for most of the lecture time. It is understandable कि तुम अगर 10-15 मिनट नहीं हो टोटल में, very much understandable, but at least 50 के ऊपर तो रखो. That's what I'm saying. ठीक है, that's how your attendance are marked before. मतलब तुमको अगर कोई डाउट होगा कि ऐसा क्यों है, so I'm telling you the logic behind it. Okay. Just give me a minute. और कुछ बचा है क्या देखने दो. Okay. this is a example of what I just told you. ठीक है, ये एक था. There is, wait, there's something more. Okay, there is a small topic in the syllabus called as conceptual address domains. So nothing that you don't know, ठीक है? But since it is ये academically उसको क्या है? Conceptual address domains refers to the logical categories or classifications of addresses used in networking to identify and communicate between devices. तो types of addresses क्या है? Physical address मतलब MAC address, okay? जो if you do IP config hash slash all in your command prompt, you'll get the MAC address. फिर logical address domain मतलब अपना ये, I'll just type it out in chat. ठीक है? So first is what? Physical address. ठीक है? Second is logical address. Logical मतलब अपना IPv4, IPv6. ठीक है? These are logical addresses. Okay, they are in the network layer. Then it is port address domain. ठीक है, refers to port numbers used at transport layer. Okay, port address domain. Port address domain, yeah. And also in this calculation, if you go in between and come back again, it's fine, those minutes are calculated, मतलब तुम्हारा total वो बन जाता है. ठीक है, that another point. Anyway, so there is physical address in conceptual. This conceptual address domains, you have physical address, logical address, port address domain. उसमें कैसे, like HTTP का 80 है, HTTPS का 443 है, SFTP का FTP का 21, SFTP का 22, that sort of thing. ठीक है. Then there is application address domain, मतलब www.google.com, www.facebook.com, india.government, okay, india.in, something like that, nike.in. ठीक है. These are all application address domains. Then we have multicast address domains. Cast address domains, ठीक है, and उसकी range is 224 to 239.255.255.255. Why it is used? It is used for one-to-many communication. Example of one-to-many communication is our radio station. या फिर this conversation that is going on, that I am speaking, you all are listening, so there is one-to-many communication. Okay, या फिर जो promotions होते हैं, like Apple promoting their new product. Okay, if it is going online, where where it is one to many communication, सामने से आने की कोई जरूरत नहीं है. Okay, so the range was 224.0.0.0 to 239.255.255.255. ठीक है. And last, broadcast address domains, which is present in every subnet. It is the last address of a particular subnet. ठीक है. It is all ones in the end, ones in the host portion. I hope you remember an address consists of two parts: network portion, address portion. All ones at the end is the broadcast address. All zeros at the end is the network address. A mixture is a host address. So our last conceptual address domain is broadcast address domain. एंड इसमें होस्ट पोर्शन का सारे लास्ट में अगर वंस होंगे तो इट इज ब्रॉडकास्ट एड्रेस डोमेन्स. ठीक है. एंड विद दैट unit 3 is completed. We'll move on to unit 4 in the next lecture. Yeah, all done. type of NAT वगैरह. I'll post it in the chat. Yep, that's it. All right, thank you so much.
Thank you, sir.
Thank you, sir.